Okay, thanks so much. It's great to be here today. My name is Vicky Clarke. I'm a sound and electronic media artist from Manchester, UK. This year, I'm really excited to be guest artist in residence with Novars at the University of Manchester. This is in collaboration with Prism at RNN. I'm really pleased to be part of the new unsupervised machine learning for music working group between the two institutions. So for the residency this year, I'm exploring machine learning and music concrete. I should say my practice is about sound sculpture and electronics, and I'm very interested in human-machine systems, how we relate to technology through exploring sound. So my research question for the residency is, how can concrete materials and neural networks project future sonic realities? For those of you who may not know, music concrete or concrete music uses recorded sound as raw material, which is then manipulated by different electronic media. So if we look back to the kind of beginning of this history with early tape machine experiments, such as Pierre Schaeffer at UoM in Paris in the 40s, and also the pioneers of the BBC radionic workshops, such as Daphne Oram and Delia Derbyshire. And then also think about the different types of media used today in terms of sampling and working with recorded material, such as drum machines and samplers, or different DAWs like Ableton and Logic. So there's different tools that we've used throughout history to sort of manipulate this recorded material. So a key concept to music concrete and to my residency is this idea of the sound object. So the sound object is distinct from musical aesthetics. It's about purely recorded material or sound without context, sound with unknown origin. And thinking about that in terms of machines, so a machine ultimately has no musical nuance or understanding of the origin or context of sound. So it's therefore interesting to think about what sounds will be generated by a machine learning model and what that means for composition and aesthetics. So my residency is focusing on a very particular type of machine learning called neural synthesis. And this uses a training data set of audio materials and trains on this data and tries to detect patterns and features within the statistics to generate or synthesize new audio. And specifically, I've been using so far Prism Sample RNN, which has been developed at the RNCM. And my key areas of critical exploration have been kind of quite a general question, is that could machine learning be a modern tool for music concrete to compose with and perform with? What's the materiality of neural synthesis? What does this generated audio sound like? And as an artist, where's the autonomy? Where's the creativity? What do you decide? What do you collaborate with the machine? So in the first phase at the start of this year, I started to build this training data set of concrete sounds. So here's my kind of training data set classes. So I made lots of recordings of different sounds. So I had a class called Echoes of Industry, which was recordings of Manchester mill spaces. I had different material sounds of glass, wood and metal from sculptures. And then I had sounds of noise and machinery. And I wanted these very distinct classes because I wanted to kind of test the model to see, could it generate new architectures, new types of sound materiality that I hadn't worked with before. So this was the kind of reasoning behind these very distinct classes. So I created a data set that was around 90 minutes of sound objects or tiny fragments of sounds. So I can share with you some of the input material and some of the output material from that process. So here is just a sample of the glass sounds that I was working with. And this sound now is the first neurally generated sound from the concrete data set. So in this sound, for example, this is raw sound generated by the neural network. I can hear different architectures and different materials that I hadn't heard before. So combinations of things like glass and static, electromagnetic sounds, and different kind of improvisations that the machine is generating. So then the question for the artist and the composer is, what do I do with this stuff? How do I make this into a performance or something that's compositionally interesting? So back in June, our group unsupervised were working towards our first sharing of this work at the Future Music 3 event, which was at the Royal Northern College of Music. So my first experiment with neural synthesis was called Aura Machine, and the piece sought to take the listener on a journey through training a neural network. So showing the process really of what happened to the sound object and those sound materials. So it started very much with the input sound, so the raw concrete training data, sounds of materials. Then it went through a transmutation stage to represent the training of the model and the feature extraction. And the end of the piece was basically the generated audio from the AI. And I wanted to keep the sounds quite pure so people could almost compare and contrast and hear what the clear reality of neural synthesis was. So since then, I'm now in phase 2. For the 10-minute piece, which was online, I wanted to kind of create a visual language, a symbolic language to kind of accompany these sounds. So I worked with a style GAN, so worked with visual AI, and I created a new training data set of kind of icons, which were ancient alchemical symbols, some electrical circuit symbols, and some technical media objects too. And the picture on the left is some of the original kind of icons that were generated out of that training. So I then work with these materials to kind of make visuals and turn these into 3D objects. So for the next phase, I can share you my process here. So I'm now starting to create sound sculptures, so physical objects that have come out of machine learning experiments. So here you can see on the left-hand side, I started with the training data, so those icons that I just mentioned. I worked with these style GAN to generate these machine icons, and then took this imagery to then through a few different processes, such as working in 2D, working in Blender, so kind of extrapolating these shapes to create them into forms, and then working with sort of prototyping tools like 3D printers to make these into physical objects that can be fabricated. So yeah, I've just received the first one back last month, and this is the first Aura Machine sculpture. This is made out of steel. It's about 60 centimeters wide, and this is going to be an acoustic object. So you can see on the left-hand side, there's a contact microphone, and I'm going to use this within a live performance system to start listening to the sounds of these AI-generated shapes. This is object number 2. This is my neon glass sculpture. This doesn't sound at the moment, but my third sculpture will be an EMF detector, so you'll be able to listen to the sound of this neon. So very much like the idea that I'm making this kind of physical and material feedback system that will go into a live show. So yeah, since September, I've been collaborating with my colleague, Sean Clarke, who's a digital artist from Manchester, and he's taken my AI-generated icons and the visuals I made for the piece in summer, and he started to make them into an audio reactive piece. So we're working together to create this live set. So we're very much in rehearsals. We've done a few live tests, and it's an ongoing project. And yeah, thinking about in terms of music. So now I have these samples to work with. I'm thinking about how I can perform live with AI. So I'm starting to build a new Euro-rack system where I can take the recordings and samples and manipulate those in real time, also bringing sound sculpture into the system. So yeah, I'm very much thinking where this will go in the future, and I can share with you my updates as I move along. So I'll just play you a quick, maybe 30-second image here. I'm just going to pause it there. And then next year, I'll be thinking about accessibility of AI and machine learning and working with Brighter Sound, which is a music education charity in Manchester. And we're going to be looking at some very accessible tools for machine learning to really kind of open this out and kind of share, these compositional new tools with other people. So thank you for listening, and I'll hand back to Costas.